Assalamu alaikum. My name is Rauful Hassan, student of Mechanical Engineering in University of Engineering and Technology Lahore, studying in Mechanical Department, session 2018 and registration number is 2018 ME173. Today I am going to present about machine tools and machining lab, and my topic is plasma arc cutting or machining. First of all, I will be giving introduction of plasma arc machining. Plasma arc machining is a material removal process. The removal of material takes place by directing a high velocity jet of high temperature, which is about 11,000 to 30,000 degrees Celsius, ionized gas on a workpiece. In this narrow plasma jet melts the workpiece material in its path. With high temperature involved can be used for any material which are resistant to oxy-fuel gas cutting. Now what is plasma? Plasma is the mixture of free electrons, positively charged ions and neutral atoms. It is obtained by heating gas at high temperature so that it is partially ionized. The central zone of plasma reaches a temperature of 15,000 degrees Celsius and it is fully ionized. Heating of a gas takes place in restricted region of nozzle duct, resulting in high velocity gas exit. Next we have the generation process. How plasma is generated. Plasma is generated by heating a gas at high temperature which ionizes gas molecules, and popular method for generating plasma are two methods which are being used for generation of plasma. First of all, we apply electric field across the columns of gas container, and second method is exposing gas column to radiations. Next we have the heating of a gas. When gases are being heated, different processes can occur. First of all, ionization of gases can take place, which results in the production of electrons and ions and different positively charged ions. Second, if we are heating the gas, elastic and inelastic collision between the atoms can occur. In this way, more collision with the atoms, and it will create high temperature, and thermal kinetic energy of the molecule will increase, which upon further collision produces ions and electrons. Thus a matter which is formed is called plasma. It is characterized by ability to conduct electricity, which are due to the free charges produced in the heating of the gas molecules. Next we have process. The gases are heated and charged to plasma state. Plasma state is a superheated. Superheated means it is a very high temperature. At very high temperature, and electrically ionized gases at approximately 5,000 degrees Celsius. These gases are directed on the workpiece in the form of high velocity stream. The gases which are used in the plasma arc machining are hydrogen, nitrogen, and oxygen. Plasma arc can be used in cutting, welding, and spraying and different methods. Now, what is the apparatus used for plasma arc cutting? The main parts of plasma arc machining are as follows. Power supply is about 1000 ampere and 200 volts. Gas supply is about 1.4 megapascal pressure, and cooling water system should be available, and control console and plasma torch should be available. Now what is the power supply? Plasma arc uses DC power supply. The power supply should have saturation current beyond which current should not rise even for short circuit. It is for easy ignition and maintenance of arc, and OCV must be higher than the load value. Supplied current value should be higher than the load value. Now DC motor generator sets or transducer controlled rectifier units with saturable core reactors are used. Now gas supply. Any gas can be used. The pressure can be up to 1.4 megapascal, which results in the velocity of 100 meter per second. The gas flow rate is directly proportional to the momentum of plasma jet. If the flow rate of the gas is higher, then momentum of the plasma jet will ultimately be higher. If the flow rate is high, then it helps to remove molten material from the melting zone. Hard objects such as alloy, steel, carbon are cut with the hydrogen or nitrogen, and it is mixed with the compressed air. Non-ferrous alloys such as vanadium and tellurium etc are cut with the argon, hydrogen, nitrogen etc. Gas flow rate should be 2 to 11 meter cube per hour. Plasma torch. In plasma arc machining, electric arc generate basic plasma jet. The nozzle arc into a small cross section. There are different plasma arc. There are different types of plasma arc. One is the plasma arc torch, air plasma torch, dual gas plasma torch, oxygen injected plasma torch, and fourth one is water injected plasma torch. Stabilization of arcs. Plasma electrical energy. Plasma converts electrical energy into thermal energy. It stabilizes the arc which burns it considered space and forced by some material. In case of the liquid vapor surrounds arc column, there is a gas or liquid stabilized plasma torches. There are three stabilization processes for plasma arc machining. Next, factors affecting the performance of plasma arc machining. There are different parameters which affect the performance of plasma arc machining. One is design and operation of the torch, physical configuration of the setup, the environment in which work is performed. Now, design and operation of the torch. In this operation aspect, there are two modes, non-transferred mode and transferred mode. And the third one, which is the exception, is turbulent and laminar mode. For design aspect, the plasma torch is designed for the maximum thermal output. The factors which affect the performance in design are cathode size, convergence of nozzle, electrode gap, orifice length, cooling of electrode. Next, we have general design considerations. Large current required, large parameters. At large arc voltage, the angle of taper should be increased accordingly. Flat faced cathode is used due to the high arc voltage. Edges of constrictions are rounded off. Non-transferred arc modes use long throat lengths, while for transferred arc mode, the minimum length is used. There should be no leakage of water. Oxygen or compounds of oxygen in the plasma gas are confirmed. Next, parameters of process. In this power supply is DC and voltage is about 200 volt and current should be 50 to 1000 amperes. Power should be 2 to 2000 kilowatt. Primary gas which is used is composition of hydrogen, nitrogen, which is about ratio. Hydrogen should be 90% and nitrogen should be 10 percentage. Now pressure, what should be pressure? The pressure should be about 10 bar. Flow rate. Flow rate should be 50 meter cube per minute. Next, cutting parameter, tool, plasma jet. Obviously, we are doing plasma jet cutting, so tool will be plasma jet. The velocity will be 500 meter per second, and the maximum temperature for the cutting is 16,000 to 20,000 degrees Celsius. The maximum plate thickness which should be cut is 200 millimeter, and cutting speed is 0.1 to 7.5 meter per minute. Next, cutting speed. Speed depends upon the material. If the material is thick, then it will be require lower speed as compared to the thin material. The value of cutting speed of different materials are as follows. We can see in the table, stainless steel have 75 thickness and arc current 800 and cutting speed is 380, while 130 thickness and 1000 arc current and 150 cutting speed. For aluminium 75 thickness 900 arc current should be there and cutting speed is 760 millimeter per minute, and 180 thickness 1000 arc current and 180 millimeter per minute is cutting speed. Brass, for brass 13 thickness 400 arc current and 1780 millimeter per minute, while titanium 13 thickness 400 arc current and 2285 millimeter per minute cutting speed. Applications. It is used to make cuts in electrical materials, used for cutting grooves in hardened shafts. It is used for underwater cutting. Plasma arc can be used for depositing filter material on the surface. It is used for profile cutting of different materials. Next, we have advantages. Carbon steel plates which are thicker can be cut faster, about 10 times faster than oxy fuel cutting. accuracy of 0.8 millimeter up to 35 millimeter plates, and 3 millimeter up to 150 millimeter plates. Sharp radius up to 4 millimeter possible, and 38 millimeter can be obtained. Smoother surface can be achieved. Magnesium, tellurium, copper, nickel, and zinc uh, alloys of copper and nickel can be cut with it. It is used for profile cutting for different materials. Next, we have disadvantages. Taper on the workpiece may occur. Production of burr on the surface. There are different burr produces on the surface of the workpiece. It alters the surface magnetically. Smoke and noise produced in this process can affect the worker. Sharp corners are difficult to make, and the process produce haze. Thank you very much. This was all for plasma arc machining.